Okay, this is Go Math Lesson 7.3, and today we are talking about algebraic expressions. So yesterday we talked about a numerical expression. And so a numerical expression, Expression is conveying something, it's telling us something, and a numerical just has number right in it. It's a number, right? So think of words like numerator or stuff like that. We make those connections and then that helps us understand. So a numerical expression might be something like 7 plus 2 equals 9, right? And that's easy enough. You know, I say, well, yeah, Mr. W, I've done that for years and years, and you're absolutely right. But if I wanted to move to an algebraic expression, that might look something like this. 7 plus a equals 9. Now, we can see that they're essentially the same thing. 7 plus some number I don't know equals 9. And most people go, and 7 plus 2 equals 9. But really what we're doing is we're saying, if I take 7 away from both of those, let's just subtract it. And just like with fractions, when I say whatever I do to the bottom, I do to the top, whatever I do to the top, I do to the bottom. This is my middle piece, right? That's my equals. Whatever I do to the left, I do to the right. I can take 7 away from both of these. And that doesn't matter because they're still balanced, they're still equal. And when I do, I get A equals 2. So in your head, you could easily say, well, Mr. W, I know that 7 plus 2 equals 9. Yeah, but as we move into harder problems, this is really all we're doing. An algebraic expression is different from a numerical expression because it's algebraic because we're using letters to hold the place of numbers we don't know yet. And so people tend to go, well, I have to do math with letters and that's weird and I don't know how to do that, right? But you realize you're not actually solving with the letters, you're solving for what the letters represent. The letters are just holding that space. So we could just as easily do this. And you could say, all right, so some blank space, 7 plus something equals 9. And then you realize we just turned this into a second grade problem. And in second grade, you were essentially solving algebraic expressions. They just left it blank instead of putting A in its place. So let's go ahead and work on creating or writing some algebraic expressions. So an artist charges $5 for each person in a cartoon drawing. Write an algebraic expression, which means I'm gonna have a letter in it. Now this letter is called a variable. That's a letter that can vary. Its numbers. A is not always 2. A is sometimes 7, and in this problem it might be 1/2, and in this problem it might be negative 3,000. It varies. So A is called a variable. An algebraic expression will always have a variable. For the cost in dollars, for a drawing that includes P people. So P is the number of people. So I have the number of people, $5 times the number of people, and I will just make this times the number of people in the picture will give me the total cost. And I might say C equals cost, right? So my algebraic expression could be 5 times P equals C. And you say, well, I don't know how to solve that because I don't know what P is and I don't know what C is. You're right. That's why they're variables, because they change. So for example, if the number of people in my picture is 2, 5 times 2, C equals 10. If the number of people in my pictures is 5, 5 times 5 equals 25. The cost is 25. You realize this is essentially just any business that you've gone to, the number of items that you're purchasing times the cost of the items determines your total value. But it's the same formula. The cash register brings it up the same way. They just put in one number and it solves for the other number. So this is where the variable comes in. Because if I change P, and it could be 2 in this case, it could be 5 in that case, it's going to also change C, right? So again, my algebraic expression takes what I know into consideration and helps me solve. So in this case, quiz scoring, multiple choice is worth 2 points and short answers worth 5 points. This is a little bit more up my alley for when I'm grading papers. The table shows the number of points that items on a quiz are worth. Write an algebraic expression for the quiz score of a student who gets M multiple choice and S short answer items correct. Okay, so M is multiple choice and S is the number of problems that I get for multiple choice and short answer. Well, I know that every short answer is worth 5, and I'm going to block those into one thing, right? So 5 times whatever short answer numbers I get. I get 3 short answer, I get 15 points. I get 4 short answer, I get 20 points. As I'm getting all animated here, I'm turning my board, getting it moving. So multiple choice is worth 2 points. 2 points times the number of multiple choice that I get correct. And then I'm going to add them together to get the score. Now I'm going to change that because that's not 5. I'll just call it X for now. So I don't know what the total score is, because I would take, on a spreadsheet, maybe if I were grading one of your papers, I would take, say, 4 multiple choice that you got correct. Well, that's good for 2 times 4, that's 8 points. And 3 short answer, 5 times 3 is worth 15 points. So I put them together to get your total score. So when I'm reading down through here, it's going to give me a variable that I need to work with. And then I take what I know about that variable and I turn it into an algebraic expression that I can use to solve it.